Question 2a. Outline what is meant by a field of force. Now, a field is a region of space, area, volume of space, in which a charge or a mass experiences a force. That can be either an electric field or magnetic field or a gravitational field. So it's a in space where a charge or mass will experience a force. Now, here we are given, it says 5 particles A to E are each placed in a different type of field. Complete the table to identify the nature of the field in which each particle is situated. So we basically got three, as I just mentioned, 3 different types of fields. You've got your gravitational, which obviously is linked to your mass. This is always attractive. This is always an attractive force. You've got your electric field due to charged particles. This can be either attractive or it can also be repulsive. And you've got your magnetic field, and this can also be, again, attractive or repulsive depending on both the charge and the direction of the charged particle. Here it's depending on the charges, and here it's always attractive. So let's have a look. So we see here it's uncharged, it's stationary in the direction of the field. Well, uncharged electric and magnetic fields need a charged particle for them to experience a force. So this must be your gravitational. So say gravitational. It's negative. It's along the direction of the field, and it's opposite to the direction of the field. So this must be an electric field, because what we've got here is actually an electron. When you've got a electric field, the direction of the electric field is always in the direction that a positive particle would take. So because the electron is negative, it will go in the other direction, and it's always in line with that direction of it. So that's electric. Now we get positive, normal to the direction of the field. Now, and normal to the direction of the field, this must be magnetic, because remember this formula over here, this sine of theta, if it's when the angle between the field and the direction is 0, then this is 0. But when this is 90 degrees, sine of theta is equal to 1, and therefore you get a force acting. So this must be a magnetic field. Positive, normal to the direction of the field, and the direction of the particle is direction of the force in the direction of the field. This must be an electric, because we have here that the direction of the force is in the direction of the field. That must be electric, because you may have a particle here, a positive particle, it's going across the field line like that, but still the force will be in this direction. The force in the particle will be in that direction, so it would actually obviously curve like that in it, but the force is always in the same direction as the electric field. And here we have uncharged and opposite to the direction of the field. That's the initial direction, and the direction of the force is on the particle. So this in the direction of the field, this must be your gravitational. You've got your field. So perhaps you've got the Earth here, for instance. You have the Earth. You've got a rocket that is being sent out in that direction. That's the direction, but still it will experience a force backwards towards the Earth in that direction. So opposite direction of the field, and in the direction of the field it's in the same direction, so it's gravitational.